Hi everyone, we're Group 22 and today we are going to talk about our project Real-Time Image Enhancement for Visual-Inertial SLAM in Underwater Scenario. So first introduction, EUV technology has been rapidly developing in recent years. There are many applications like underwater rescue, place recognition, scientific survey and so on by using it. However, compared to land, underwater environment is a typical GPS-denied environment. Therefore, underwater image provides valuable information for robot navigation. However, the underwater image are often degraded by poor medium conditions, such as limited light turbidity, which result in low contrast and color distortion. So to solve this problem, we realized a real-time visibility enhancement algorithm for Visual-Inertial SLAM. In this project, we test Visual-Inertial OrbSLAM3 algorithm in underwater scenario and integrate OrbSLAM3 and OKVIS with a real-time image enhancement node. Also, we compare the result on enhancement and unenhanced image, which shows there's an improvement in the performance.
We use harbor sequences in Aqualog dataset, which is collected in shallow underwater environment. It is challenging because of the degraded vision caused by light absorption and illumination variations, as well as the inconsistent ground composition. We take two methods for comparison. One is the OrbSLAM3, which is the state-of-the-art SLAM method consisting of multiple threads. It firstly extracts and matches ORB features to compute the poses and decide the keyframes. Then it uses bundle adjustment to refine the keyframes points and the map, and finally do the loop closing correction and map merging based on place recognition. The other is the OKVIS. It combines the MU measurements with camera frames and processes them together. It extracts brisk feature, do the brute force matching to select keyframes and do the optimization. The underwater application has turbidity and lightning, which can lead to less feature matches. So we integrate the image enhancement model to solve this.
To improve OrbSLAM3 and OKVIS, we implemented a real-time image enhancement node for each algorithm. Here, our image enhancement technique is described. First, we use guided image filters to compute foreground and background filtered images. These images are subtracted from one another to create a residual image. The residual is overlaid on top of the background image to create the detail image. Lastly, we use contrast-limited adaptive histogram equalization to distribute the intensity of the image such that the contrast of features is maximized. Additionally, these are the results of our image enhancement algorithm on selected key points. You can clearly see that the enhanced versions allow for significantly more matches with both algorithms. The matching results from sequence 1 of the Aqualog Harbor dataset are shown here. With both methods, the enhanced version yielded significantly more matches, which causes more accurate resulting landmarks and trajectories. On sequence 1, unenhanced OKVIS drops below the matching threshold, which causes a complete loss of tracking. With our image enhancement, this no longer occurs. An important factor to consider when implementing SLAM methods is the practicality of implementation on actual hardware. We ran several tests to compute the effect of our image enhancement algorithm on CPU load. On our hardware, we have proven that these algorithms remain suitable for the majority of real-time applications.
We compare the trajectory estimate with and without image enhancement in two SLAM framework. We can see that, especially in OKVIS architecture, the enhanced image sequence gives closer estimate to the reference trajectory. We also evaluate the trajectory estimate performance using absolute translational error statistics. The result indicates that in both of the SLAM frameworks, the image enhancement technique could reduce absolute translational error. And especially in OKVIS cases, the error and its standard deviation reduced significantly.
In conclusion, real-time image enhancement resulted in improved feature matching and tracking performance for both OKVIS and OrbSLAM3. This is evident from our discussion on the feature matches plot and also from the absolute trajectory error plots and values. Furthermore, complete tracking failure was significantly less common when tested with real-time image enhancement. One limitation that we faced was that OPSLAM-3 sometimes loses tracking between similar runs for both cases due to the lack of IMU initialization. This could be attributed to the lack of excitement of the ROV, which makes the initialization process a lot harder. Coming to future work, we wish to integrate pressure sensor with depth measurements to build a tightly coupled visual-inertial pressure slam framework for underwater scenarios. This is something we have attempted with OKWIS already, but are unfortunately lacking any concrete results. We hope to continue this aspect of the project further. Additionally, different image enhancement and color restoration techniques could also be implemented and compared with. We can also test this on different underwater conditions and look at the performance. These are the different references, and thank you for listening.